What are maxima and minima of a function? So here we have the definition. We will say that f of x has a local maximum at c if f at c is bigger or equal than the value of f at every point x near c. Okay, so we can imagine something like this. This would be our point c, and this would be our value f of c. We will have a local minimum if f of c is smaller than the value of f at points near c. Okay, so we can think about something like this. Here are point c, okay, and our value f of c. Okay, we can see that it's this value is smaller than the values of f around. Now, let's be careful with the terminology, because sometimes this can be confusing. So the absolute maximum or minimum of f occurs at the input c. Okay, and this is important. And the maximum or minimum value is f of c. Okay, so we need to distinguish very well what is, when we ask the minimum value of the function or the maximum value of the function, we are asking about f of c. When we want the maximum or minimum point, we want the input c. Okay, that we need to be very clear about that. Let's see some examples, because here we are saying local maximum, right? So let's say we have the sine of x, and I'm standing in this point. So this point, what is the value of f, the sine of x at this point? The value would be 1, okay? And the value 1 is the largest around that point, right? If I go very far, then I will be back to 1. But if I just look around, all the values of f around that point are smaller than 1. Okay, and what is this point here? Let's look at the trigonometric circle. Oops. So the sine is equal to 1. This, for example, will be pi over 2. Okay, but we see that it will happen again and again every 2 pi. Okay, so we can have pi over 2. Well, this is pi over 2. So the maximum value, let me write it properly. The maximum value of the sine of x is 1, and it is attained at x equals pi over 2 plus 2 pi k. Okay, and this k will be 0, 1, well, 0 plus minus 1 plus minus 2 and so on. Okay, but I could also be looking at this point over here, where the sine is -1. Okay, I could be here, and I would be at the minimum point, you see, because all the points around are bigger than the value of -1 that I get at this point. And what is this point? So we can see in the trigonometric circle that will be negative. Well, actually, I'm on the positive side, so that will be 3 pi over 2. So I have the minimum value of the sine of x, which is -1, and it's attained at x equals, we can write 3 pi over 2 plus 2 pi k. 0 plus minus 1 plus minus 2 and so on. Okay. And here comes the interesting thing. When we look at this function, these are what we call absolute maximum and minimum. Why? Because there are no other points for which the value of f is larger for this particular function. Okay, the cosine actually works similarly, but let's define carefully what I mean by absolute here. So definition, f of x has an absolute maximum at the point C if f of c is bigger or equal than f of x for all x in the domain of f, wherever f is defined. And then I have the corresponding definition for the minimum. Let me copy paste. So the changes are just the sign here, right? So it's an absolute minimum if f of c is less or equal than f of x for all x in the domain of f. Okay, so now it's clear that the value 1 and the value -1 actually gave a minimum and the maximum that were absolute for the sign of x. And now let's be careful about this. Not every function, warning, not all functions have absolute maxima or minima. Okay, for example, we could have the function f of x equals x to the power 3 minus x. Here we see that the roots are 0 and plus or minus 1, right? So it's going to look something like this. Okay. But what happens here? So as we go towards the right, the function is going to keep growing. And as we go towards negative infinity, the function keeps decreasing. Okay. So we will never be able to find a value that is smaller than all the values of the function f, or that is bigger. Okay, so there is no absolute maximum or minimum, but we have these 2 points here, right, that are local, that are local extrema. This is a local minimum, and this is a local maximum. Okay, and they are a local maximum and minimum because the points around them, okay, even if we go quite far, the points around them are smaller than the value at that point. Okay. All right, so now something that we would like to know is how can we find those points where the maximum and the minimum are attained, and what are the values of these local maximum and minimum. We will see that in a moment. Let me give more examples. So the easy ones, we could think about a parabola, right? a parabola open up. This one will have an absolute minimum at x equals 0, but no maximum. And we can have the opposite situation when we have a parabola open down, right? Let's say this is 1 minus x squared. In this case, we have an absolute maximum and no minimum. Okay, the function just keeps going down as we go to negative infinity or infinity. Now, you may have noticed something here. How is the tangent at the points where there is a minimum or a maximum? It's a horizontal tangent. Okay, the tangent at the maximum or minimum point is horizontal. Okay, what does that mean? Horizontal means the slope is 0. And the slope is the derivative. So f prime of x equal 0. Okay, so what are we saying here? At every point where there is a maximum or a minimum point, f prime of x has to be 0. But here, let's be a little careful again. What we are saying that all maximum or minimum points of a differentiable function, because if it's not differentiable, f prime makes no sense. Okay. These points of maximum minimum must occur at points where f prime of x equals 0. But not all points where f prime equals 0 are maxima or minima. Okay, an easy example is the function f of x equals x to the power 3. Okay, in this case, f prime of x is 3x squared and is equal to 0 if and only if x is 0. Okay, but let's look at the graph for a moment. At 0, it has an inflection point, but that's not the maximum, neither a minimum. Okay, in fact, this function has no maximum, no minimum. It's ever growing. Okay, let's go back to our original example with the sine of x. So we already guessed the values of the maximum and the minimum, right? But let's compute them. So the derivative of the sine is the cosine of x, and this is equal to 0. Where is this equal to 0? Looking at the trigonometric circle, the cosine is equal to 0 at the north and south pole, okay? In pi over 2 and 3 pi over 2, right? Pi over 2 plus 2 pi k, or 3 pi over 2 plus 2 pi k. And here again, k is 0, plus or minus 1, plus or minus 2, and so on. With this means that I can take turns on the positive direction or the negative. Okay.